So in the previous tutorial video, we learned about the initializer notation, which is approach 1. So now we move on to creating the same array over here using approach 2. And then we'll try to run a for loop to iterate through the array to print out every element, show you a little bit on the debugger for the second notation, and then we'll try to trace the loop this time, which we didn't do quite nicely in the previous tutorial video. So just for completeness, we're going to trace the code for you. Okay. So now let's go on to create a new class over here. So the same package over here, default package, right click and say new and class. Okay, let's simply do integer array 2. Okay, approach 2. Integer array number 2. And we're going to use individual assignments to achieve the same purpose. And then we try to see how we can automate the same achievements using try to really print out the elements out using the loop. Okay, that's what we will do. And one thing to note, as you can see, the array that we are trying to do in the previous tutorial and this video over here, there is no pattern between the elements of the array. You can see the number 940, 880, and also 830, etc. So these numbers do not really have a common pattern for us to really automate their setup using a loop. However, in the next video, I will actually show you another sequence of number in which case you can actually initialize the array using a loop. Okay, so whether you can really initialize the array using a loop or not, it really depends on the example you're dealing with. Okay, but I just want to show you examples so you can see. Okay, so now integer array 2 and generate the main method and say finish. Okay, so now let's do something very similar to what we did before. Okay. And you can recall, I can somehow reuse a little bit of the previous value over here, but I'll try to see what to use. So this is the one you did previously. Okay, so now I will simply just okay, let me just leave this. Okay, but go to integer array 2. Okay, so approach number 2 is going to work as follows. Approach number 2. Okay, it contains the following steps. Create an array of integer of size 10, for example, right? You can choose whatever number of elements you like, but in this case, since we talk about this array here, which got 10 elements inside, okay? Okay, and then you will say use separate assignments, each of which initializing an element in the array at a particular index. Okay, let me just change the line over here and I'll show you exactly how to do it. Okay, apparently approach 2, you will have to learn about some new syntax. Okay, so now for approach number 2, what we do is like this. First of all, declare an array. The way you declare the array will be just the same as before. So you would say integer is the elements, is the type for each element for every element in the array, but it's an array of integer. So you're gonna put empty pair of square brackets over here, right? This notation here is really important. And then I'll say IA. Okay, so now rather than using on the right hand side using the array initializer notation, what I would do is I'll simply say you gotta use a keyword called new. Okay, that's something new for you. So you gotta learn about this new keyword. New, and then I will repeat the declaration of the integer array, but now this time inside the pair of square brackets over here, I need to give some integer expression. For example, I can just give a number to say how large the array is. Of course, this number may come from the user entering an integer, which I'll illustrate to you maybe in a later video. But for now, let's say we already know the size of the array. So I can simply say 10. Okay. So now as soon as we have done this, I'll show you in the debugger, but after this line number 12, we're going to create an array of size 10. Which means every element is already allocated in the memory, but we haven't stored any meaningful value just yet. But we're going to do that. Okay? But I'm going to show you exactly. Also, there's a minor detail you want to pay attention to. As soon as we create an array of size 10, there will be some default values that is stored for every slot in the array. And for the default value for integer is simply just 0. And the value 0 over here is not really important, but we want to, I'll show you anyway. Okay. After this, we're going to assign to individual elements here. So I can say IA at position 0 is assigned to, okay, now I can just make use of the value from before. Okay, let me just copy this part here, okay, from the previous one, so I can reuse the value. Okay, so I can remind myself. Let me just put it here. Okay, the first value should be 940, and then let me just copy this line here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, it looks tedious, but this is the only way we can do it, because there's no way to really use a loop to automate this, because there's no pattern between the elements of the loop between the array elements. There's simply no pattern. But in the next video, I'll show you a sequence where there's really a pattern between the elements of the array. In which case we can use a loop. But in this case, no, you have no choice. 3, 4, 3, 4, and 5, 6, 7, 8, and 9. Okay, let me just cut and paste. 880, 830, and also 790, 750. Okay, 660, 650. Okay, 590. And also 510, and also we got 440. Okay, of course you're going to type it out. You don't have to do the cut and paste like what I'm doing here. Okay, so basically this will achieve the same array that we did previously in the previous tutorial over here, like just using an initializer notation, like what I'm highlighting here. So the two are completely equivalent, so you can choose which one you like. Okay, however, the advantage of using the array initializer notation is it's very convenient. You write everything in one go, just one line. However, this assumes you know exactly the elements you want to put into the array. On the other hand, if you try to use array 2, the approach number 2, like what I'm showing here, you may put these assignment in separate places in your program. Okay, but that's kind of according to experience. But for now, I'll just show you how to do it programmatically. Okay, after this, we can simply try to print out the loop, use the loop to print out all the elements in the array. Okay, so now, okay, how about this? Let me just say what this will achieve. Create an array of size 10 where each slot of the array stores the default value for the integer type. Remember, every element in the array is of type integer, right? In this case, 0. Okay, I'll show you this in the debugger. Okay, and then also we're going to assign each slot of the array to a value. Okay, so we just do for index 0, index 1, index 2, all the way to index 9. Okay, so now let's say we want to print out. Okay, so now we want to process the array. Okay, that's the exciting part. So now we can say print out each element in the array from left to right. When I say from left to right, I simply is the leftmost index should be 0, and all the way to rightmost index will be 9. We'll talk about in the lecture later how you can print backwards. Okay, but let's not worry about it for now. Okay, how do we print it out? So what I would do is I can simply just go back to integer array 1 over here. Okay, what I would like to do, I will simply just want to copy this version 2.3, which we did in the previous video. I will just take this one verbatim. It will just work. Okay. However, for now, for this current video, I'm gonna trace this fragment of code with you together. Okay, to make sure you got complete understanding. Okay. So the way we iterate through the array in version 1 and version 2, I mean approach 1 and approach 2, is just identical. Okay, so now let me simply copy this fragment of code, and then let's make sure everything works, and then I will trace it together with you. Okay, so now I'm gonna paste this fragment of code to iterate through the array. I'll simply say paste. Okay, so everything compiles. So now I'll simply execute this code. Let me double click, and now right click on array integer array 2.java, run as Java application. So what do I have? Okay, I got exactly what's expected. right, over here on the console. So everything works. So now what I would like to do is I want to show you a little bit on the debugger for what's going to happen after executing line number 16 and what's going to happen after every individual line over here. And then I want to trace. We already did this in the debugger, but I want to trace this together with you on the iPad to make sure you got a complete understanding. Okay, that's what I would like to do. Okay, that'll be the plan. So now, first of all, let's run the debugger. What I will do is I'll put a breakpoint in line number 16. So this is right before we try to declare the array IA and try to initialize that to be an array of size 10. That's exactly what we would like to do. Okay. So now, before, you know what? Just before I forget, let me just put some notes over here so I remember. So the last thing I would like to do for this current video after tracing the program, I would say, show how to reassign the array. Okay, so this is something you cannot do. Remember what we said before in the approach number 1. When we were in approach number 1 in the previous tutorial video, I mentioned that you simply couldn't simply say once I created IA for the first time, I want to reassign that into another array of different size or different contents using the initializer notation. Again, it's simply forbidden at a syntax level. However, in the case of the approach number 2, you can actually reassign the array using this approach 2. That's something I want to show you in the last thing for this video, but let's not distract our attention. Let's go back to the tracing part. Okay, that's actually also very important. Okay, so now I put the breakpoint at line number 16, and now I'm going to run the debugger. Okay, so now right click on integer array 2.java, and then I'll say debug as Java application. Okay. So now you will see that I'm now pausing at line number 16 right before I try to execute this line. Okay, let's think about what's going to happen. Let's anticipate first before we see what's actually going to happen. So we're declaring an array IA of size 10, basically. So that means we're going to create an array from indices 0 to index 9, right? From 0 to 9. That's why we got 10 elements inside. 0 is always the first index for the array. Okay, so don't forget about that. So now the question is, what's going to be the value of the array? Remember in approach number 1 previously, after we put this line over here, as we show in the previous video in the debugger, after we execute line number 13 in approach 1, what's going to happen is index 0 of the array IA is going to be 940, index 1 is going to be 880, right, etc. And also up to index 9 will be 440. But what about in approach 2 in this case? Well, we haven't assigned anything. It's not going to happen until line number 21. So what's going to happen after line number 16? So this is why I said each slot is going to store the default value for the integer type. In the case of Boolean array or character array or string array, there will be other default values. But I would say for now, let's focus on just integer array for this particular tutorial video. Something for you to remember. Every time when you create an array of certain size to begin with, all the slots will just be filled in with default values for integers, in which case it's 0. Okay, let's double check with this. So now what I would do is you can see the variables over here, we haven't seen IA just yet. Okay, but as soon as we say step over. So if you see over here, step over, click on that. So now you will see IA over here, and you can see as soon as I click on IA, it shows me the nice representation over here. You can see every slot simply stores 0. Let's double check with that. You can also see over here, IA over here, at position at index 0, the value is 0. At position 1, at index 1, the value is 0, and all the way to at index 9 over here, the value is 0. Let's also double check from the expression watch. If I go to expressions over here, if I say let me delete the previous one. If I right click on that and then I say remove all, okay, and so we don't get distracted. So now I can do IA at position 0, okay, and now we know that's 0. Let's also, for fun, I can say IA at position 0 equals compare that with 0, and also IA at position 1 equals 0, for example, right? You can write out the very long conjunction, and also you can say IA at position 2 also equals 0. that would just be true, right? Because all the slots are simply 0. Okay, just showing you how powerful it is to actually use the expressions panel over here. So you can write any expression you like that you're interested about knowing their values. Okay, so now as you can see over here, at the moment, if you look at the variables over here, IA is simply of simply every slot in the array is simply just 0. So now we're going to change them one by one. Okay, so now we are pausing at line number 21 right before we try to execute this particular reassignment. So what is it going to do? So now this is simply saying, so now on the left hand side, so far the assignments notation, so this is an assignment instruction as we covered in the previous tutorial video. So far, before we talk about array, the left hand side is simply just a variable like an x, or it can be I, can be s. But now we're learning about a new kind of left-hand side of the assignment, which can be a particular index position of the array. So what does that mean? Very straightforward. It simply says now we want to go to position or index 0 of the array, which is over here. Go to this particular cell over there, and then assign whatever that's on the right-hand side, which can be any integer expression in this case, assign that into this particular position. Okay, what does that mean? That means now we want to say assign position 0 over here, index 0, assign the value to be 940. Okay, so now watch what's going to happen. If I say step over and watch exactly under the variables over here and see for index 0. If I say step over, okay, you can see for index, you can see this is the only line that's highlighted in yellow. So that means the only thing we changed by stepping over line number 21 is we changed the index 0 value to be 940, right? So now if we execute again, you can see what would be the line to be highlighted in yellow. It should be the one over here, right? Let's double check. If I say step over again, you can see now it is line. It's actually for index 1 in the array that's now being reassigned to 880, right? That's exactly what happened. Okay, you can simply just go over this one by one. So now if I simply step over again, step over again, step over again, you can see it's just keep changing the value for the array one position at a time, right? Do it again, do it again, do it again, do it again. So now the last one. So after these 10 assignments over here, you can see now we have achieved an array that's just the same as the array over here. Okay, that's why I call it the second approach. Okay, and then we're gonna run this loop over here to print out every element in the array from index 0 to index 9. Okay, so now I'm gonna stop the debugger here because we already run a debugger in the previous tutorial video for the loop. You can refer to the previous tutorial on how to interpret the debugger for the loop. But now I want to do a slightly different, slightly different angle to do the tracing. I want to do it manually with you, okay? Which is a very important technique for you to pick up as well for yourself. For example, if you try to answer the quiz or to answer some written questions without a compiler, without a debugger, you want to know how to trace by hands. Okay, let me click on terminate over here to stop the debugger, and then I will go back to the Java perspective on the top right corner. So now what I would do is I'm going to basically just copy this fragment of code, and then I'm gonna trace that on an iPad together with you. Okay, let me simply do a screenshot over here. Okay, just this fragment of code. You can see only 3 lines, but that will require quite a bit of explanation, which we'll do very carefully together. Okay, so now let me switch to iPad, and now let me have a new page over here. Let me paste the code. Okay. Okay, so this is the for loop we have. Okay, that's clear enough. And now let's also, you know what? Let me move this a little bit downwards. I also want to copy the array that we have set up previously. Okay, so now this is the array that we have set up, that we're convinced is being set up properly. Okay. Okay, and then we're going to paste the array at the top. You know what? Let me put this a little bit downwards and move this a little bit downwards. Okay, that's proper organization. Okay, good. So now let's try to trace this fragment of code. And now the best way to trace a loop is by drawing a table. And the table should have multiple columns, but at least you should really have at least one column for the value for the loop counter, in this case I, and also one column for whether the state condition is true or false, and also one column for what's the effects for the executing the body of the loop. In this case, let me tell you, in this case, what should we trace? We want to trace the value for I. We want to trace the value for this particular state condition. So we should see that it's going to be true, 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 true until it gets false, which means we have to exit from the loop. And also we want to trace also the value for what's this particular expression over here, IA at position or at index I. What's the value over there? Okay, so these are the three things we would like to trace. Okay, so now let me draw the table quickly for you. Okay, so this is exactly what you have to do on the paper by yourself. Okay, so now I'm going to draw a table over here. Let me make it a little bit thicker. Okay, I'm going to have one column for I, and also one column for the state condition, and also one column for IA at index I. Okay, and also we should know very well that this particular I++ is going to be executed at the end of each iteration. Let's keep that in mind. Okay, so now let me write down the expression we're going to trace. So we have the value for I, and also we have I less than IA dot length. Oh, by the way, what's IA dot length in this case? Let me write it down for you. For this particular IA dot length is going to be, you can see from 0 until 9 is basically the maximum index plus 1. Okay, it's simply just 10 elements inside. Okay, so now let's make a note over here. IA dot length is simply just 10. Okay, in this case, okay, since we're treating this particular example, so let's know what IA dot length is. And then also we got another expression to trace, which would be IA at position I. So sometimes when I say position, I really meant index. Okay, IA at position I. Okay, let's see what it is. So this will be printed out to the console. So now let's see exactly what's going to happen. And remember what we said in the previous tutorial video. It is really important that you know that this should be strictly less than. If you try to do less than or equal to, if you try that, it's eventually going to give you something called array index out of bound exception. Okay, as we'll see very quickly at the end. It's going to be array index out of bound exception. You know what? Let me just put it a little bit better. If you try to do less than or equal to, okay, it's a reminder over here. Okay, if you simply say less than or equal to, it's going to give you array index out of bound exception. Array index out of bound exception. Okay, it's a very important for you to know why it is the case. But as we'll see, as we trace through the table, you're going to see exactly why. Okay, let's try. So now, what's the initial value for I? Okay, as you can see, I'll put the initial value first. You can see that. Let me use blue. Okay, I is simply initialized to be 0, so I can put 0 over here. Okay, and then we're going to evaluate this state condition here for the very first time. So we got 0 less than IA dot length is simply 10. So that means we get true. True means we're going to execute the body of the loop for the very first time. And we're going to print out elements of IA at index. Now in this case, it's going to be I, which is just 0. Okay, and then what's going to be the value for this particular expression over here? So now we're talking about IA, this integer array over here at position 0. Right? So now it's going to be IA position. Okay, let me change to blue. Okay, it's going to be integer array variable IA at position 0. Now in this case, position 0 is exactly this element here. So it's going to print out 940. So this is why when you see back in the Eclipse over here, let me just execute the original program again so you will see exactly. So remember the very first output will just be 940, right? Okay. So now let's try. Okay, so now at the end of the iteration, we're going to execute this I++. All right. When we execute this I++ over here, so that means I is going to be incremented from 0 to 1. Okay, and then we just and then once we have done that, we're going to evaluate this particular state condition over here for the second time. So that means we got 1 less than 10, which is going to give me true. Again, so that means we're going to execute the body of the loop, for the second time, right? And now we're going to say elements of IA at index in this case is going to be 1, right? And then what about this expression over here? So now this time is going to be IA at position 1. You can see the beauty about using a loop over here to iterate through the array, because the value over here for the index over here is going to change as the iteration goes further each time, because the value for I over here simply change. The I value over here is simply changes every time that we go through from iteration to iteration. That's the beauty about using a loop. That's something you really want to get used to. Okay, so now what's IA at position 1? Well, this is position 1. The element stored at position 1 for IA is simply 880. Okay, that's exactly why you see 880 over here. Okay, so now basically you can do this kind of tracing until you actually get to the very last iteration. Let's try. Okay, we know that it's going to be from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, right? And all these is going to make the state condition true, because 2 less than 10, 3 less than 10, 4 less than 10, 5 less than 10, also 6 less than 10, 7 less than 10, 8 less than 10. All these will simply just give you true. And every such iteration is just going to give you a different elements at a different index, right? So now if you look at that, so for this particular one, it's going to give you I8 at position 2, and which is going to be 830, right? That's exactly what you will see over here, 830. Okay, I'm doing this very slowly just because it's really important for you to really see every step being executed. So now what about this line here? It's going to be IA at position 3. The reason we are doing this is because the state condition is still true, right? And then at position 3 is going to be 790. And then what about here? So that'll be IA at position 4, and now it's going to be 750. Okay, and then we have this line here. It's going to be IA at position 5, and that's going to be 660. And also over here we have IA at index 6, and now it's going to be 650. And here we got 8th iteration, right? So if you think about the iteration, what's the iteration number? If you think about the iteration over here, somehow you will see this kind of correspondence as we discussed in the class. Okay, when the value of I is simply just 0, or let me just use red over here. When the value for I is simply 0, that means we run the very first iteration. When it is 1, we run the second iteration, right? And etc. Okay, I'll complete this in just a moment. Okay, and then what about here? So now here we got IA at position 7, and which is going to be 590. And over here we got the IA at position 8 over here, and then we got it's going to be 510. Since like we are not done yet, right? So now how many iterations have we got so far? So that's 3, that is 4, that is 5, that is 6, that is 7, that is 8, that is 9. You can see the relationship between the I and also the loop counter and the iteration number. It's always I plus 1, which will give you how many iterations we have done so far. So now we have done 9 iterations so far. So now, because we got 10 elements, we should really expect to do 10 iterations. So we got 1 more to do. Okay, let's finish that. And we have to see exactly how things will work. Let me just move this table a little bit up. Otherwise, I'm running out of space. Let me do that very quickly. Okay, like that. Okay, so now at the end of this particular iteration, we know that we're going to execute I++ another time. That means we're going to increments from 8 to 9. And then 9 less than 10 will still give me true. So that means I'm still going to go into this particular body of the loop, and they're going to say element IA at index 9. And over here, what should be IA at position I? Let's figure that out. So IA at position 9 in this case will just be 440. Okay, and we know very well this is the 10th iteration. Okay, so now here comes the critical point. The state condition cannot just stay true forever, in which case it's really a logical error, because for running any loop, you want to eventually exit from the loop, so you don't really keep consuming the resources of your computer. So now, what's going to happen at the end of this particular iteration is we're going to increment the value of I from 9 to 10. Let's try that. I'm going to use a different color. From 9 to 10. And then here going to evaluate, again, I less than IA, the length is going to be 10 less than 10, which is going to give you false in this case. So this is really important for you to see. You can see so far we have evaluated 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Out of the first 10 times of evaluating the state condition, we get true. That is why we have executed the body of the loop for 10 times. And now for the 11th time that we try to evaluate the state condition, it becomes false. Okay, which is exactly over here. As soon as the state condition over here of the loop becomes false, we have to exit from the loop. That is why nothing to be done. Okay, for calculating this line, nothing to be done, because we simply, as soon as it becomes false, we simply just go outside the loop and then exit from the loop. That is why you see the last line we got printed out was simply for index 9 and then 440. So that's exactly this last row that you see over here. Okay, so this is really the last one. Okay, so this is the last iteration. Okay, so hopefully you can see this kind of tracing over here. I know it's very kind of tedious to trace, but I would say as the problem of your code, as the problem that your code is trying to solve gets more complicated, this is kind of the technique you want to have in order to debug the program yourself. It's really important for you to get comfortable with this kind of tabular tracing. Okay, so now let's see what else. Okay, so this kind of complete a picture of tracing the loop. Like in the previous video, we simply use debugger, and in this case, we use the iPad using the tabular tracing manually. Okay, please make sure you're comfortable with both. So now, one more thing to say before I end the video. As I promised, I'm going to show you how to reassign the array. Okay, so what do I mean by that? Again, if you recall in integer array 1, approach number 1, if I simply say IA is reassigned to another initializer for the array, this is not allowed syntactically. It just cannot be done as a Java syntax. However, for approach number 2, let's say I want to reassign the array. For example, conceptually, this is what I want to do. I want to say IA rather than pointing to an array of size 10. What about I want to say IA should really point to a new array that looks like this. That is simply just going to have, let's say, index 0, 1, 2, 3. I got 4 elements in the array. Let's say I want to have 14, 23, minus 3, and 4, for example, right? So let's say I want to have this array instead. How do I do it? Okay. So now, what I can do is I can simply say IA, for which I don't have to declare. It's already declared previously, which is declared over here in line number 16. Okay, I'm just reassigning this particular array. So now I can say IA is reassigned to another new array. I can simply repeat this line, this right hand side over here, but with a different size. I can say it's assigned to new integer array, and what's the size? Let's say what we want to achieve over here is pointing to a new array of size 1, 2, 3, 4. Okay, so I would say as size 4. Okay, so this will compile. And then after this line, pretty much like after this line over here. So that means IA after this line here is going to point to an array of size 4. And then all the elements in the array will simply be the default value for integer, meaning 0. And then I can say IA at position 0 should be reassigned to something. It should be 14. Okay, 14. Let me do that very quickly. Copy 1, 2, 3. 3, 2, 1. Oops. 1 over here. So 14, 23, minus 3, and then 4. Okay, that's what I can do. And then after this, I can simply print it out again. Okay, let me just put a separator over here. So now I can say system.out.println. Over here, I can say after reassigning IA to a different new array. Okay, this is after that. Okay, so you can see exactly the difference. First of all, let's execute the code, and then I'll show you in the debugger for these two parts to see exactly what the change has been imposed. And then for this part here, to trace this, I will leave that as an exercise for you, because that will follow just exactly like this particular table over here. But the number of rows for you to trace in the table will be much smaller, because now in this case it's only 4 elements in the array rather than 10. Okay, so now let's try to execute the code. If I try to execute, you can see that, so this is before the reassignment. We simply got the original array of size 10. Okay, over here. And then after reassigning, so this is after this particular line over here, so what we have is we simply get elements of IA, the same array, but it's now pointing to a different array, right? It's now pointing to, rather than this, it's now pointing to the pink one, which got 4 elements there. Okay, so you can see exactly over here, right? So that's kind of a very important thing for you to know how to do. So now I will put a breakpoint at a different line and then show it to you. Okay, double click. So now I will put a breakpoint. Let me see if they got any. I want to remove the breakpoint at line number 16. Okay, and now I want to put a breakpoint at line number 44. Okay, so now that means if I try to run the debugger, I'm gonna pause at line number 44. That means right before I try to do this particular reassignment. So now, as soon as I pause over there, IA is still pointing to this particular array of size 10. But as soon as I execute a step over line number 44, it's going to now point to this particular new array over here. Initially, every element will just be 0. And then I'm going to reassign every element using an individual assignments over here and then print it out using a loop. That's the procedure. Okay, let's try. So I will say run the debugger over here, make sure it's going to debug integer array 2. And then I try that. And then it's going to pause at line number 44. So now, as I mentioned, let's verify for variables. By the way, you can also check one thing. If you go to expressions over here, okay. So now let me just delete the previous one. Okay, I just don't want any distraction. So now let me just remove them. Okay, right click on the expression and say remove all. At the moment, if I simply say ia.length, so it's 10. Makes sense because IA is still pointing to this particular array of size 10. It's right before we try to execute this particular reassignment. It's before that, okay? So, and also if you look at the console over here, if you look at the variables over here, expand IA, you got index 0, index 1, index 2, up to index 9. We got 10 elements. Also, if you press the IA, it shows you everything. Okay, so now let's predict what's going to happen. If I say step over line number 44, what it's going to do is it's going to reassign IA to a new array of size 4, where every element is simply just 0, the default value for int type. So if I say step over here, you can see now IA is no longer pointing to that array of size 10 with these values, right? Anymore. It's simply just pointing to another array. So now IA is now pointing to an array of size apparently 4 over here. You can see index 0, index 1, index 2, index 3. All the positions simply store 0. And also, if you look at the expressions over here, IA.length has now changed from 10 to 4. Okay, Again, if you don't see the variables and expressions, you can simply go to Window and Show View, and then find them out from here. Okay. Okay. So now, if you go back to variables over here, so now we want to assign them individually. Okay. Let's try. So now, if I step over line number 46, I should see line index 0 to be changed from 0 to 14. So if I say step over, okay, it's exactly index 0 that's been changed to element to value 14. If I step over line number 47, I'm going to see index 1 has been changed to store the value 23. If I step over again, you can see index 2 is now storing -3. Okay, lastly, if I say step over again, you can see index 3 is also changed to 4. So now, how we're going to run a loop to see exactly how to really print out every element in the new array. Okay, so now for that part, I'll refer you to do a very important exercise for yourself. So you want to really draw a table and then to trace exactly how you're going to trace how exactly this loop will be executed when it is pointing to this particular array. Okay? How many times, in this case, are you going to check this state condition over here? How many times? Number one. Number two, how many times are you going to execute the body of the loop? The answers for these two questions will be different. Okay? So please review this also in the lecture notes. Okay, let me stop the debugger over here. Okay, let me recap and then we are done. Okay, basically in this particular video, we are showing you basically approach 2 for creating an array. Approach 2 over here, which means we simply use individual assignments and we create an array of certain size for which every element initially simply store the default value for the data type for the array. In this case, integer type, the default value is simply 0. And then we use individual assignments to assign every slot one by one. Okay, that's what we did. And also we try to trace how to iterate through the array using a table. That's the most important part for this video, really. Okay, other syntax you can pick up very quickly, but this is the technique, the soft skill I want you to really grasp. Okay, so now we go back here, and also this is also very important. So now for line number 44, we simply reassign this. Remember, variable simply means you can reassign the value that is stored in the variable for as many times as you see necessary. Now, IA is simply just a variable. It's simply a variable for an array. So that means you can reassign as many arrays to this IA as you like. Okay, so now we simply reassign this to a second array of size 4. You can feel free to actually reassign IA from here to another array of size 100, and then reassign that to another array of size million. Okay, it's completely up to you. Okay, so now, however, one more thing reminder: in the case of approach number 1, if you're using the initializer notation, it simply cannot reassign the array like this. Okay, so now you want to really review approach 1 and approach 2 very carefully before you go on to the next video.